All right, let's dive right in. Today, we are opening one of the biggest, most fascinating case files in all of science, the hunt for life beyond our own planet. And I want you to think of this as a true investigation, okay? This isn't science fiction. We're talking real clues, real suspects, and some seriously cool detective work. So let's get to it.
So let me ask you something. When I say the word alien, what pops into your head? You probably picture something from the movies, right? Maybe a little green man or a giant spaceship. Go ahead, get that image in your mind and hold on to it. Because we're about to completely flip that idea on its head and talk about what the first alien we find will probably actually look like.
And right away, here is the first major twist in our investigation. I want you to just forget everything you've seen in the movies for a second. Because the most important, the most universe-altering discovery we could possibly make might just be bacteria. Yeah, really. Some scientists even call it microbial scum. But finding even that, that would change everything.
You know, this quote right here really gets to the heart of how scientists think about this now. It's not so much a question of if there's life out there anymore. The real question is, where is it and how do we find it? The starting assumption is that it's not just possible, it's probable. And our job as cosmic detectives is to follow the evidence and prove it.
Okay, so to have any chance of finding life out there, we first need to get a better handle on the toughest, most bizarre life right here on our own planet. We have to look in places we used to think were totally, completely impossible for anything to survive.
And that brings us to these guys, extremophiles. I mean, the name pretty much says it all, right? They love the extreme. These are the organisms that are our best guess, our blueprint, for what alien life might actually be like. They're our working model. I mean, just stop and think about this. Here on Earth, we have found entire ecosystems that have never seen the sun. They don't need it. They live in complete darkness, deep under the ocean, deep under thick ice sheets, and they get all their energy just from chemical reactions with minerals and rocks. This is so important because it proves a point. If life can make it work here, in some of the most hostile places imaginable, then why couldn't it find a way somewhere else?
All right, so if we're the detectives in this case, what are the clues we're actually looking for? Well, when we point our telescopes and probes out into the solar system, we have a pretty specific checklist. You can think of it as the recipe for life. And here they are, the 3 essential ingredients. First, you need liquid water. It's the ultimate solvent, the place where all the chemistry can happen. Second, you need an energy source. That could be sunlight, sure, but it could also be heat coming from inside a planet or moon. And third, you need the right chemistry. The basic building blocks, like organic molecules. You need the stuff to build life out of.
Okay, we've got our recipe. Now it's time to bring in the suspects. Let's do a little lineup of the most promising worlds right here in our own backyard and see which ones have what it takes.
First up, the usual suspect, Mars. Now, on the one hand, it's got some things going for it, like plenty of frozen water. But the downsides, they're huge. You've got a super thin, toxic atmosphere, it's brutally cold, and the surface gets blasted with so much radiation from the sun that it would just shred any complex molecules. It's just a really tough place to be alive today.
But this is where things start to get really interesting. Let's look at suspect number 2, Jupiter's moon, Europa. Now check this out. Underneath that thick, icy crust, scientists are almost certain there's a huge, salty, liquid water ocean. There could be volcanic vents on the seafloor providing energy, and we've even seen stuff on the surface that looks like organic material. So let's see. Water, energy, chemistry? Yep. Europa seems to tick all the boxes.
And then there's Saturn's moon, Enceladus. And this one is incredible because it's actively handing us the evidence. It's literally spraying samples of its hidden ocean out into space through these giant geysers. And we've flown a spacecraft through those plumes and tasted them. And guess what we found? Water, organic chemicals, and all the signs of an energy source. It's like Enceladus is screaming at us, hey, I've got everything you're looking for right here. And that brings us to our final suspect. And this one is the real wild card of the bunch, Titan. It's Saturn's largest moon, and it's just different. It's wrapped in this thick, soupy orange atmosphere, and it looks like nothing else in the solar system. So, what makes Titan so fascinating is that it could host a totally different kind of life. See, it's got lakes and rivers, but they're not made of water. They're filled with liquid methane and ethane. So if there's life on the surface, its whole chemistry would have to be completely alien to us.
But, and this is the cool part, scientists think Titan also has a regular old liquid water ocean, deep down below the surface. So it's like a 2-for-1 deal, two completely different chances for life on the very same moon.
So we've got our prime suspects lined up. The next logical question is, how do we actually investigate them? I mean, especially these ocean worlds, where the good stuff is buried under miles and miles of ice.
Well, it really comes down to what planetary scientist Tracy Becker says here. It's all about the water. The possibility of a liquid water ocean is it's too big to ignore. That's exactly why a place like Europa is at the very top of our list.
And get this, the ocean we think is hiding under Europa's ice, it's estimated to have more than twice the amount of liquid water as all of Earth's oceans combined. Just let that sink in for a second. More than double all the water on our own planet. A true ocean world, right here in our solar system.
So that brings us back to the big challenge, right? How in the world do you investigate an ocean that's buried under like 20 miles of solid ice? It's not like we can send a drill down there. Well, not yet anyway. We have to be a lot more clever about it.
And this is where the cool tech comes in. A mission like NASA's Europa Clipper is basically a flying detective loaded with a whole toolkit of instruments. It's got spectrometers that can map the surface and look for the chemical fingerprints of organic stuff. It's got a thermal camera to hunt for hotspots where something might be erupting. It's got ice-penetrating radar to figure out how thick the shell is. And it's even got an instrument that can literally sniff and analyze any particles that might be getting shot out into space from geysers. It is a complete forensic investigation, all done from orbit.
Okay, let's pull all of this together. We've got our suspects, we've got our tools. After all this searching with this amazing technology, what are we really hoping to find? What's the realistic expectation here?
And this really gets to the heart of it all. There's the expectation, right? The one we get from movies, spaceships, signals from advanced civilizations, little green men. But then there's the scientific reality. And the reality is that the real prize, the actual goal of these missions, is to find signs of a microbial ecosystem. Or heck, even just finding complex organic molecules would be a huge win.
And I really can't stress this enough. Finding even a single, simple microbe on another world would be without a doubt the most profound discovery in human history, because it would prove that the spark of life isn't a one-off fluke. It happened at least twice all by itself in just our one little solar system. And if it can happen twice here, well, that means it's probably happening all over the universe. It would completely change our place in everything.
But that leaves us with one last, kind of haunting question. We're getting ready to search these incredible worlds, places that seem to have all the ingredients for life. But what happens if we look and we find nothing? What would it mean if all those perfect-looking recipes turn out to be empty? Would that mean we're truly alone, that life here on Earth is just some kind of impossible miracle? No matter what the answer is, finding out will be one of the most important things we ever do.